Alright, video 3. Two objects in free hang. So we've done, I got it mixed up and forgot for video 4. I made video 4 first. Forgot I hadn't done this. So we've done an object on a table and something in free hang. Then an object on a table with friction and something in free hang. Now, two free hang, video 3 and 4. So then 5 for another one. So here, we'll do the theory first with formulas and then with numbers. Yeah, on the previous one, I forgot to do it with numbers first. Oh well. But in video 4, I was going to do numbers, and I forgot numbers only. But here, we need to use Newton's laws free body diagram. It helps. So in this situation, we have B, A, connected by a rope or something. So we got the tension. Then we have on A, gravity's pulling down, and that'll be to the right. Because, you know, these are connected, you get it, put it there. So gravity's pulling down. So force of gravity on A, then tension this way. Then on B, the tension is this way. And force of gravity is that way. So then we'll also remember that, like in a coordinate system on the x-axis, to the right is positive, to the left is negative. So we write our equations from this stuff. Then for A, we got force of gravity is positive, tension's negative. So, you know, this would be like Fg plus negative T, and that's like Fg minus T. And that'll be the mass of A times acceleration. Since they're connected, acceleration will be the same. And the tension in the rope is uniform, the same. And here, whoops. So this time, tension okay, and if it helps, like I'm keeping this straight in my head, but at first, the tension's the same, but these are different, you know, so this is like for B. If you want to put a B there, to help you remember FGB, FGA. And so, if that helps you, to keep the two separate. So, A, B, because the force of gravity comes from the same acceleration, but it's a different mass, okay? So, FGA minus T, so the pull downward decreased by the tension. The tension slows it down like. And tension minus Fg, because we're considering direction, keep it uniform. So if we get it and put it out, right is positive, left is negative. It helps us keep stuff straight. Then, this time I'll do it like a system of equations. If we add down, instead of solving for T, T minus T is 0. So the T's subtract out. And we have FGA minus FGB. Is MAA, MBA, Then, to solve for acceleration, factor that out. I'll rewrite this. So this is going to be the mass of A times acceleration due to gravity, mass of B, acceleration due to gravity, and then divide. And here, let me do this first. We can also factor that out. Factor out a G. So mass of A minus the mass of B times G is mass of A plus mass of B times A, divide so like that. I'm going to come up with variation in another video with one thing on an inclined plane, just this modified. Because on an inclined plane, instead of all the force of gravity, instead of all of it being along the incline, only part of it is. So we got that, MA, A, MBB, FGA, FGB, MA, MB, factor of the G, cool, okay. So when they're like this, here is our formula. Positive to the right, negative to the left. Then we'll do a particular example. So, rewrite my formula over here. A is MA minus MB over MA plus MB G. Okay. Then, I'll do this problem. I'll post a link to the worksheet. So we got A will be 5 kilograms. And B, 2 kilograms. Then we'll get acceleration and tension. I gotta get back to my tension formula. I can just use one of them. So mass of A, 5 kilograms, mass of B, 2 kilograms. Let's get acceleration and the tension in the rope. So acceleration, ta-da. So acceleration will be 5 minus 2 over 5 plus 2 times 9.8. So 3 over 7. So 3 divided by 7 times 9.8. Whoops. 3 divided by 7 times 9.8. 4.2. meters per second squared. And it's positive, so it'll be down this way, 'cause it's to the right. To the right would mean down for this one. And so, we get these guys, lay them out in a line. A here, B here. Gravity's pulling against B on A, and gravity's pulling against A on B. So for A, we consider gravity the force positive. For B, we consider it negative for the straight line thing. Then we know that if our answer is positive, it's going to the right, which would mean down. If it's negative, it's going to the left, which would mean down for B. So we get 4.2. Acceleration. Then, if we look at A again, remember gravity to the right. Back in the free body diagram, minus tension is MAA. We got the acceleration now. Solve for tension. Move T over, move this over. T FGA minus MAA. Some simple algebra. You know, add T to both sides. Subtract MA from both sides. You end up with this. Then the force of gravity on A is just the mass of A times G. And then if we factor out MA, this is G minus A times MA. So the tension in the rope would be 9.8 minus 4.2 times 5. Then we get 9 parenthesis 9.8 minus 4.2 parenthesis times 5 equals 28. Do I have that in right? 9.8, 4.2, 28. Tension 28 newtons. Okay. So then we'll see how long it takes to fall 2 meters. So okay, there we are. So now we got that stuff. Now, how long does it take for block A to fall 2 meters? So here we're doing our equations of motion. Get back to this. Click here. Okay. So we look at our given information. The distance, which is D for most people, S in IB speak, IB International Baccalaureate, 2 meters. Acceleration, 4.2 meters per second squared. And how long does it take? Time is unknown. And initial velocity, we have that. And that's like a U in IB speak. Let me see, we could do D is that. So we could do D is initial velocity times time plus 1/2 AT squared, or in IB speak, S is U T plus 1/2 AT squared. And of course, initial velocity is 0, so that's gone. So we just have D is 1/2 AT squared, or S is 1/2 AT squared. Then put our stuff in. 2 is 1/2 4.2 T squared. Half of that is 2.1. So T squared is 2 over 2.1. So we get square root 2 divided by 2.1. Enter. 0.976. 0.976 seconds. Which is why we want to do some of this, to get practical basic information. How long does it take to fall? Or let's see what the velocity is. So if we want to do what's the velocity after it falls 2 meters? So initial is 0. The final velocity we're trying to figure out. Again, we look at our equations, find the one that has these things in it, and it's going to be for most people, or in IB speak, so then we plug in, and our velocity 0 squared plus 2 times 4.2 times 2, and then square root. So what about 4? 2 times 2 is 4, 4 times 4 is 16, so the velocity would be approximately 4. But see what it does exactly. Square root 4.1 approximately. So there. So we can get the stuff and do more with it, just depending on what's asked. Find for a certain distance how long it takes. For a certain distance, what's the ending velocity? Stuff like that. All right. So 1 or 2 more videos to go.